and welcome to yet another session where we shall be looking at the proposed memorandum of the grade 12 mathematics paper 1 for November 2024. Okay, so the paper was out of 150, 3 hours was the duration of the paper. And then looking at the instructions, this time we have 12 questions. Okay, all questions are compulsory. We have to number questions according to that. Okay, clearly show the calculations, diagrams, and graphs that you have used in determining the answers. So we need to show all our workings. We have the calculator good, and then the rounding off is still 2 decimal places. Diagrams are not accurately drawn, and then we have the information page. All right. So question number 1, as usual, it is the algebra. And 1.1, they want us to solve for x. So what we can do, or what we can see, is that 1.1.1, we have dot product, or we have vectors. So x multiplied by x minus 3 is equal to 0. So in this case, either the x is a 0, or the entire bracket x minus 3 is equal to 0. When we solve this, x must give us a positive 3. So x is a 0, and then x is a positive 3. Those are the two answers for 1.1.1. Then 1.1.2, we say whenever we have correct 2 decimal places, that's going to be the quadratic formula. But before we start with the quadratic formula, we need to create the standard equation where everything needs to be on one side of the equal signs, and then we should be left with a 0 on the other. So that's going to be 2x squared minus 4x plus 1 is equal to 0. Okay, so from that, we can notice that our a is a 2, and then our b is a negative 4, and then our c is a 1. Then all we have to do is substitute into the quadratic formula. Let me just put it aside. So it is 2x squared, okay, minus 4x plus 1. So x is negative b plus minus the square root of b squared minus 4ac over 2a. So that's going to be negative and negative 4 plus minus the square root of negative 4 squared minus 4 times 2 times 1 divided by 2 times 2. All right, so simplifying that, I'll have a positive 4 plus minus the square root. We know that 4 squared gives us 16 minus 4 times 2, that's 8. So 16 minus 8 is going to give us 8 divided by 2, which is a 4. All right, then when I punch this into the calculator, I'm going to have 4 plus the root of 8. Saying 4 plus root of 8 over 4. That gives me 1,71. And then the other value, if I use the minus, I'm going to get 0,29. Okay, so that is what was expected for the formats. Then 1.1.3 is the quadratic inequality. So let's vectorize that. That's going to be x. That's also going to be x. We can have a 3, we can have a 1. Let's make this a negative. Let's make that a positive. Okay, it's greater than 0. So the critical values in this case, okay, critical values, we have x being a negative 1, and then we also have x being a positive 3. But now we know that the inequality is greater, and the a is also greater than 0. The a is positive, and then the inequality is greater. So which means either x should be less than negative 1, or x must be greater than 3. So x is less than negative 1, or x is greater than 3. So that is how we would work that out. Vectorize this out, get your critical values, and then represent the solutions. Alternatively, you can draw the parabola, okay, where we have something like that. So that's a negative 1, and then that is our 3. So we're focusing on these regions. All right. So this is the region of interest. That's the region of interest. All right. So that is 1.1.3. Then 1.1.4, we have some exponents. And with these exponents, we have 2 to the 2x minus 2 to the x plus 2. Okay, let me just use the blank page so that I have more space, okay? So this is 1.14, 1.14. So 2 to the 2x minus 2 to the x plus 2 minus 32 is equal to 0. We confirm that. It's a plus, minus, plus, good. So what I can see is that even if I'm to split this up, I'll have a 2 to the x, but this is a 2 to the 2x. So I can select maybe k be equivalent to 2 to the x. Okay, split that up, 2 to the 2x minus 2 to the x multiplied by 2 squared. Okay, so when I multiply these, bases are the same, I must add up the exponents. Minus 32 is equal to 0. So if k is 2 to the x, which means that's going to be k squared, minus 4k minus 32 is equal to 0. We can factorize this, use your quadratic formula or the factors. Okay, the two numbers I multiply to give me 32, and when I add them, I get negative 4. That's going to be 8 and 4. This should be a negative, that should be a positive. Okay, so either k is a negative 4 or k is a positive 8. Alternatively, if you couldn't do this, you can just factorize straight away with the k being the 2 to the x. Okay, should also give you more or less the same thing. So let's replace k with the 2 to the x. So 2 to the x is equal to negative 4. Or we have 2 to the x is equal to 8. But in our knowledge of exponents, we don't have anything that we can raise to another number and it gives us a negative answer. So this one, we don't have any solutions. It's not applicable. Then the second one does give us something. So 2 to the x is the same as 2 cubed. The bases are the same, which means x must be a 3. So that is how we would attempt 1.1.4 for these 5 marks. And then 1.1.5, where we have the third form. So step number 1, we isolate the root. So that's going to be negative 2x plus a 4. Okay, is equal to 2 plus x or x plus 2, either way. So that is step number 1. Step number 2, we need to square both sides. Okay, the moment we square this side, the root falls away. So we're going to be left with negative 2x plus 4. Let me just put it aside. Negative 2x plus 4 is equal to, we have x plus 2 squared. Okay, so x plus 2 squared, square brackets, that's going to be x squared plus 4x plus a 4. Okay, then I can create a standard equation. Let me move everything to the right-hand side. So that's going to be x squared plus a 4x plus a 2x plus a 4 minus a 4 is equal to 0. So this 4 cancels that 4. We only have this. So x squared plus 6x must give us a 0. Let's factor out the x. We have x plus 6 is equal to 0. So either our x is a 0 or our x is a negative 6. So since we're dealing with a third equation or an equation that has a root, we have to test our values, okay? So initially, the question was, let me change this. It was the square root of negative 2x plus 4 minus x, we must get a 2. Okay, let's use a 0. So if we replace x with a 0, we're going to be left with the square root of 4, which is a 2. Now we are subtracting 0. 2 minus 0 gives us a 2, which means this value satisfies the equation. We're going to keep it. Let's try the negative 6. So negative 2 times negative 6, that's going to be positive 12 plus 4, which is a 16. Square root of 16 is a 4 minus a negative 6, which becomes a positive. Okay, so which is going to give us a 10. 10 is not the same as 2. So this one is out or not applicable. Just cross it out or just put NA, not a solution. Okay, this is not a solution. All right, so we've done the testing, so we qualify to get all the 4 marks. 1.2, the simultaneous. So we have this as equation number 1. Let's call that equation number 2. So from equation number 1, we need to make y the subject because it is easier. So I need to move the 2x to that side, which means my y is going to be 3 minus 2x. Let me call that equation number 3. And then I'm going to substitute this third equation into equation number 2. So I'll have 3 minus 2x. Everything is squared plus, okay, x, and then 3 minus 2x must give us a 2. Let me do the substitution on this other page. Okay, so we have 3 minus 2x. That is squared. We said plus x into 3 minus 2x. This must give us a 2. All right, so let's open this up. So when you open this square bracket, 3 squared is going to give us a 9. 3 times 2 is a 6 times 2, which is minus 12x. And then 2x squared must give us a positive 4x squared. When we open this, that's going to be 3x minus 2x squared. Let's move the 2 that side. Must give us a 0. Let's collect the like terms. So that's going to be 2x squared. Okay. We have this and this. We should give us negative 9x. Then 9 and 2 must give us a 7. It's equal to 0. Let me try to factorize 2x and x. Numbers I multiply to get 7 has to be 7 and 1. If I put a 7 here and I put a 1, my middle term is a negative, which means that should be negative so that I get a positive 7 here. Okay, that's 2x squared minus 2 minus 7, give us minus 9. Perfect. So in this case, x is going to be 7 over 2. So x is going to be a 1 if I use this bracket. X is 7 over 2. If I use this bracket, x is a 1. Okay, so we need to substitute these values into equation number 3, which equation was telling us that it should be 3 minus 2x. 3 minus 2x. So substitute x into equation 3. So that's going to be 3 minus 2 times 7 over 2. This must give us a negative 4. That's the first y value. Or 3 minus 2 times 1, which must give us y as a 1. So x, we said 7 over 2, or x is a 1. So those are the solutions that we needed for us to get those 5 marks. Okay? So that is how I would have approached that question. 1.3, consider the product. This number is familiar, probably either May, June, or October, November last year. We had more or less the same scenario. And then they asked us for the product of the whole thing. Okay, no problem. So each factor is in the form of 1 plus 1 over n. If n is greater or equal to 2. Determine all the values of n for which the product will be an integer. Now, when you talk about an integer, it's either we're dealing with positive or negative whole numbers. Okay? Now, what we need to understand is that if we look at the first bracket, let's change this into an improper fraction. That's going to be 2 times 1 is 2 plus 1. That's going to give us 3 over 2. Then 1 plus 1 over 3, that's going to give us 4 over 3. And then that's going to be 5 over 4. Now, if we are multiplying, okay, if we are multiplying this whole thing, we can see. Let me just put it this side so that I have enough space. Okay, so we say this 3 over 2, 4 over 3. 3 over 2, 4 over 3, 5 over 4, and that's going to be 6 over 5, and so on and so forth. Now, they told us that the nth term or the factor is in the form of 1 plus 1 over n, which means if we are to continue, would end up with a 1 plus 1 over n. Now let's change this also to an improper. So that's going to give us n plus 1 over n. That's our last term. Now, we need to identify something or some sort of a pattern, okay? Now, this pattern is, we cross this, we cross that. We cross that, we cross that. We cross this, we cross that, we cross that. And so it's just a matter of canceling everything out, which means in this term that is here before this last term, this n is also going to cancel with the n somewhere there, okay? And then whatever is here must also cancel with that and so on. So which means we are only left with n plus 1 over 2. Okay, in other words, this is our product. Okay, so the product is given as this. Now, what we also need to know is that for this whole expression to be an integer, okay, we shall say that for n plus 1 over 2 to be an integer, in other words, for it to be a whole number without necessarily giving us a fraction. Remember the condition for n must be greater or equal to 2. So which means if we use a number like 3, it's going to be 3 plus 1, which is 4. 4 divided by 2, then we get a 2. Okay. If we use a number like 2, 2 plus 1 is 3. 3 over 2 is going to give us 3 over 2, which is not an integer. So we're saying for this to be an integer, the n plus 1 must be even. Okay, this whole thing, the numerator must be even. And if it is even, n needs to be odd, because we have already a plus 1, which makes the whole thing whatever. Okay, so if that is true, okay, if that is true, we're going to say that for n is greater or equal to 2, for this, the values, they say the values of n will be all the odd numbers. We said what? N needs to be odd. So it'll be all the odd numbers that are greater than 2. Odd numbers greater than 2. Or you can say that n is going to be greater or equal to 3. But if we say this, then it's not going to make sense. So rather would say n must be 3, 5, 7, 9, and so on, for as long as it is odd numbers. Okay, all the odd numbers that are greater or equal to let's just say greater or equal to 3. So greater or equal to 3. Okay, so if you put a 3, you're going to get a whole number. If you put a 5, you're going to get a whole number and so on. So we cannot go into the negatives because our n must always be greater or equal to 2. All right, so that is how 1.3 would have been approached. It's a question with statements and explanations. All right, question number 2. The first term of an arithmetic is 7. Okay, so our A is a 7. The common difference D is a 5. And then the number of terms we're talking about will be 20. Calculate the sum of the series. So from the formula of the sum, from the formula page, n over 2 to A plus n minus 1 into D. Let's just do the substitutions. That's going to be 20 over 2 into 2 times, that's going to be 7, plus we know that 20 minus 1 is going to be 19 multiplied by 5. Okay, let me just reaffirm my answer. That's 2 times 7 plus 19 times 5. The answer, I'm multiplying it by that. So it's 1090. 1090. All right. 2.1.2 performance. The original arithmetic is extended up to 75 terms. Remember, initially we had 20. Now we're talking of 75 terms. The sum of the 75 terms will be given as this. We don't need to confirm that, okay? Using sigma notation, can we write down an equation for the sum of the terms added to the original using sigma notation? Okay. So my approach to this question was, one, I have the sum of the first 20 sums, or sorry, the first 20 terms. So S20 got 10, 90. They are telling us that S75 is 14400. 14400, perfect. Now they want us to represent the extras that were added to the 20, which is 75 minus that. We need the sum of the 55 terms. It's going to be 14400 minus 1090. What do we get? All right, so what I'm getting is 13310. So this is the extra that was added to the 20 to give us the sum of that. All right, then what I need to do is also get my Tn. Okay, so Tn is a plus n minus 1 into t. Our first term was a 7, common difference is 5. So 7 plus n minus 1 into 5. Open that up, 5n minus 5, which means it's 5n plus a 2. Now, having obtained my Tn, now I can write my sigma. Okay, sigma, I put the Tn formula and say 5n plus 2. Okay, because this is going to help us to get the terms. Never use the sigma. It is a symbol for summation. Okay, now we cannot start from T20. We need to start from T21. And then T21 up to 75. If we subtract these two, 75 minus 21, that's going to give us 54. Then plus 1, we have 55 terms. So this, I'm going to equate it to 13310. So this is what the question was asking for. Okay, so going back, all we needed was to get the difference between the sums to see what extra was added. Okay, so this is that. Then get your Tn in a simplified format, which is that, and then the sigma. What is important is the starting point, which is the 21st term up to the 75th term. All right, so that is 2.1.2. Then 2.2, the sequence of the first differences of a quadratic are given as that. 1, 3, 5, and so on. Okay, let me use green. Okay, so which means we have terms there. 1, 2, 3, and so on and so forth. Okay, so if T99 of the quadratic is 9632, calculate the value of T98. Okay, let me put it aside also. I say T1, T2, T3, and so on. 1, 3, 5. Now we continue telling us T99. What's the value? It is 9632. They want us to find T98. Okay, so what I want us to look at, or the trick behind this question, is very simple. We need to find the Tn of the first differences. Okay, so since it is arithmetic, it's just going to be 2n minus 1. You can use your nth term of a plus n minus 1 into d. First term is 1, n minus 1, common difference is 2. You're going to end up with the same thing. Now, what you need to note is we need to find what is the position of the difference between T98 and T99. Okay, what position is this first difference? So if 1, okay, the first term is between T1 and T2, the second term here is between T2 and T3. The third term is between T3 and T4. Okay, so which means the term that is between 98 and 99 is going to have a position of 98. So let me find this value there. So I'm going to say T98 is going to be 2 times 98 minus 1. Okay, so twice 98 minus 1 is giving me 195. Okay, now for me to move backwards, since the answer I'm getting is positive, I have to use the inverse. So T98 is going to be 9632 minus 195. Okay, so if I subtract that, 9632, I'm getting 9437. Okay, 9437. So that is the result that we are getting for T98, 9437. All right, then 2.2.2. If it's further given that the third term is a 32, okay, that is a 32. Determine the general term. So if that's a 32, if we move backwards, 32 minus 3, it's going to give us a 29. Minus 1, it's going to give us a 28. So our interest is basically the first term, which is the 28, and then the 1, and then the 2 for us to get the Tn. So we start by saying 2a is going to give us a 2 for the second difference, which means a is 1. Then 3a plus b should be equated to that first term of the first differences. But if our a is a 1 plus b, which means b is going to be negative 2. And then a plus b plus c must give us that first term, which is 28. So 1 minus 2 plus c is 28. That's going to give us a negative 1. Move it that side. C becomes a 29. So our Tn is going to be n squared minus 2n plus a 29. So that is what the question wanted or asked for. All right. So that is 2.2. Question number 3. Wow. They're telling us that a circle that is having, okay, a radius of 6 centimeters. Now, we need to know what is radius. Radius is just the distance from the center to the circumference. So which means if this we can draw, let's say this is our diameter, the distance from here up to there is a 6. Okay, so the second smaller circle is drawn through the center of the first, which means the diameter of the radius is the diameter of the second circle, which means that is going to be 6 divided by 2. That's 3, and then 3. Same thing, that's going to give us 1,5 and so on and so forth. Okay, showing the diagram, that circle is drawn through the center, and then the process continues to form a geometric. So what we can do, let's start by looking at the pattern that would be created. Okay, so if we're talking about the radius, so the first radius of the big circle is going to be a 6. The second one is going to be a 3. Since it's a geometric, which means we're just multiplying by a half or dividing by 2, which means that must be 3 over 2. So which means the radius of the third circle is going to be 3 over 2 centimeters or 1,5 centimeters. The pattern just continues growing. Then 3.2, calculate the sum of the areas of the first 10 circles. The key word in this question is the areas. Okay, it changes the entire scenario. Now, we know that the area of a circle is given as pi times the radius squared. Now, if I'm to look at the pattern that is created by the areas, I think I must take it from there. Okay, so let me see the radius. We have 6, 3, and then 3 over 2. So 6, we have 3, and then 3 over 2. This question is 3.2. So we're saying area is given as pi radius squared. So for the first term, I'm going to have pi times 6 squared. The second area is going to be pi multiplied by 3 squared. The third term is pi, and then 3 over 2 squared. So that's a 36 pi. That's going to be a 9 pi. And then this is going to be 9 over 4 pi. So these are the areas, okay? The pattern that is forming the areas. Now, when I look at this, if I get my T2 divided by T1, I'm just getting a 4, which means my common ratio is going to be a quarter. Okay, so 9 divided by 36, that's a quarter. Okay. So if this is my common ratio, now I can look for the sum of a geometric. So from the formula page, we know that the sum of a geometric is given as A into, let's use Rn minus 1 over R minus 1. Does that make sense? Yeah, it can. Or it can even be the other way around, 1 minus Rn and then 1 minus R. Whichever, let me just use that other format. But we're still going to end up with the same answer. Okay, we said A, 1 minus R to the n over 1 minus R. So our first area was 36 pi into 1 minus. The common ratio is a quarter. We're looking for 10 circles, because they said the first 10 circles. Okay, over 1 minus a quarter. So if we can do this, then the rest must be history. We just need to punch this into the calculator straight away. That's going to be 1 minus 0.25 to the exponent of 10 over 0.that. So my area is 150,796, which is the same as 80. That's going to be centimeters squared. So that is the sum of the first 10 areas, or the sum of the areas of the first 10 circles. Okay, then 3.3, which circle has a diameter of 3 over 128 for 3 marks? Okay, so now they are trying to switch us around. Remember, they started with the radius. Then we talked about the area, which has also a radius. Now they are taking us back to the diameter. Okay, let's see. When we look at the diameters, how are the diameters relating with each other? Okay, so you have 2 ways of doing this. You can still use the radii, okay, then divide this by 2, and then use the nth term of the geometric. You still get the same thing, okay? What we need is just the position, which is the n. But let me just look at the diameters. So the first diameter was a 12. Remember, diameter is from this point to that other point. That's a 12. The next diameter was from there up to there, which is a 6. And then the next one is a 3, and so on. So which means my common ratio is a half if I'm focusing on the diameters. The Tn of the geometric is AR to the n minus 1. Our interest is the n. So let me erase this out and show you how I got my n. So our Tn is 3 over 128. Our first term is 12 times the r, which we got as a half. Let's use, okay, it's okay. Let me use a half with the exponent of n minus 1. We can divide both sides by 2. No, sorry, by 12. Okay, so 3 over 128. I'm dividing it by 12. That gives me 1 over 512 is 1 over 2 to the exponent of n minus 1. All right, so what I can do, I can use my laws of exponents, okay? if I change this to a half, what is 512 in exponential form? It is 2 to the 9. Okay, so 1 over 512 is the same as 1 over 2 to the exponent of 9. 1 over 2 to the n minus 1. Okay, so let's put it here. So a half to the exponent of 9 is a half to the exponent of n minus 1. Drop the bases. 9 is equal to n minus 1. Move the 1 that side, which means n is a 10. Alternatively, you could use your logs, okay? Where someone would say that if I use the logs, it's going to be the log over half. Then that's 1 over 512 is equal to n minus 1. This should give you a 9 also. And then move the 1 that side. We still end up with 10. So this one is saying the 10th circle, or circle number 10 will have that diameter. So even if you use the red eye, you still end up with a 10th circle as your answer. All right, question number 4. Given that f of x is a to the x minus 1 for a is greater than 0. b is 2 and negative 5 over 9 is a point on f. They want us to find the value of a. So since there's just one unknown, this 1 point is enough. Let's substitute. So that 2 is for x, and then the negative 5 over 9 is for y. So that's going to be negative 5 over 9. Remember, f of x is the same as y, is equal to a to the exponent of 2 minus 1. Then we're going to move the 1 that side, which means it's going to be negative 5 over 9 plus 1. When you punch that into your calculator, I'm going to end up with the 4 over 9 as my result is equal to a squared. And then find the square root. So we know that the square root must always give us a plus or minus, okay? So that's going to be plus minus 2 over 3. But then they told us that a is greater than 0, which means a is going to be 2 over 3. The answer is 0.66 something. We prefer it in this fraction format. That 0.66 is greater than 0. In other words, it's a positive answer. That's the meaning of this part. Then they want us to give the range. Now, the range of an exponential is dependent on this mister here, which is called the asymptote. Now, since this graph is greater than 0, but the a value is less than 1, it's between 0 and then 1, which means it's a decreasing function. It's not a big deal. Y must be greater than negative 1. That must be our range. Or someone can say negative infinity is less than y, and then less negative 1. Can put an equal sign there. So it's either this format or that format. This one is quicker and better. All right, then 4.3, they want us to sketch clearly. So let me just clearly sketch it this side. F of x is a to the x minus 1. Remember, I said a is 2 over 3 to the x minus 1. So since it's a sketch, have your y and then have your x. So they told us the asymptote is negative 1. Okay, so if the asymptote is negative 1, just indicate that. Then if x is a 0, this whole thing will disappear to be a 0. We have that. Then they told us that if x is a 2, y is that, which means it's a negative value. So that's a 1, that's a 2, which would be, what is now 5 over 9? 5 by 9 is going to give me 0.55555, which is more or less somewhere there. It's okay. So which means our graph should be in this sort of format. Okay. It must pass through the origin. Okay. Pass through the origin and also move towards the asymptote. It shouldn't touch the asymptote. Now, this is our sketch that we needed. We call that F. Then 4.4, because they needed the asymptotes, they needed the axis. So we have even. So 1 mark for the asymptote, 1 mark for the axis, 1 mark for the shape. Fair enough. Then if it's further given that there is a point C on F where the y is 19/8, they want us to get the coordinates of C prime, which is the image of C after it is reflected about y is equal to x. So this is more like the inverse of that original point. So what we can do, let's get the x value. So if y is given as 2/3 to the x minus 1, they're telling us y is 19/8 is equal to 2/3 to the x minus 1. Let's move the one that side, which is going to be a plus. So 19/8 is saying plus 1. That must give us 27/8. So 27/8 is the same as 2/3 to the x. Now what I can do is that I can use the logs straight away. Okay, I have two ways of doing it. If I use the logs, which means my x is going to be log, that's 2/3, and then I have 27/8. Let me try this approach and see. If it's 2/3 into 27/8, the answer I'm getting is a -3. Alternatively, if I find the exponents, so this is going to be 3/2. Everything is cubed, because 3 cubed is 27, 2 cubed is 8, is equal to 2/3 to the x. But now I want the same base to be 2/3. So that can only happen if I switch the numerator and denominator. And that can only happen if the exponent is negative. So it's going to be 2/3 to the -3 is equal to 2/3 to the x. So since the bases are the same, drop them and then equate the exponents. Now, this simply means that the C value is basically -3 as well as the 19/8. Now, since they want the image point, which is C1, and we are reflecting it in the line y is equal to x. So what is x becomes y, what is y becomes x. So it's 19/8 and then -3. So this question was technically asking you to find the x value, mainly. This y is equal to x was just to prolong the story. Okay, then question 5. Sketch below is a graph of f of x, which is a/x plus p, which is a hyperbola, having this domain between negative and positive of +1. And then the graph casts the y-axis at 0 and 1. Beautiful. And there's a line of symmetry, which is given. Okay, so that is x minus 3. Awesome. Then 5.1, they want us to get the value of b. Write down the value of p. So we know that p represents the vertical asymptote, this line here. And we see that this line is passing through a +1, which means our p is a -1. Because if number must go with a sign before it, so if it is x minus 1, if we equate this to 0, then we shall get that asymptote. So p, I'm taking it as a -1. So if p is -1, then I need to also move on to the next question. The next question is asking us to determine the equation of the horizontal asymptote. So what we can see is that this horizontal asymptote is intersecting with the axis of symmetry. Okay. Funny enough, that horizontal asymptote is also intersecting with the vertical. So at this point here, the x is a 1. All we need is the y. Okay. So 5.2, I'm going to use this equation. So look for y when x is a 1. So that gives me -2. So which means the equation is going to be y is equal to -2, because this asymptote must be written in that format. This is x is equal to 1. Okay. And then they want us to get the value of a. So 5.3. I'll write it here. So 5.3 value of a, just substitute into the original equation. So it's a over, we said x minus 1. And then we found also that the q is a minus 2. We need just 1 point since we have one unknown. The easiest one is to use 0 and 1. Okay, so at this point, x is a 0, y is a 1. So I'm going to say 1 is equal to a over 0 minus 1. It's going to give me negative 1 minus 2. I need to move this minus 2 to that side. It's going to be a plus 3 is equal to a over negative 1. Multiply both sides by negative 1, which means a is going to be a negative 3. Beautiful. So we have the value of a. Then for which values of x is f of x greater or equal to 0? For which values of x is f of x greater or equal to 0? So where do we find the y being above the x-axis? That is the question of interest. Now, for which values of x? For 3 marks. Okay. So this graph is above the x-axis from this point here. So in other words, this question wants us to get the x-intercept. They want us to get the x-intercept. Okay, so I'll just rewrite the equation and say my f of x is negative 3, say over x minus 1 minus 2. So this negative 3 is correct because initially the graph is within the second quadrant and the fourth quadrant of the asymptotes. It's a negative anyway. Okay, so for us to get the x-intercept, we're saying the y must be a 0. So I'm going to say at which point is that? I don't know. They didn't tell us. Okay, at the x-intercept. At the x-intercept, we're saying y must be a 0. So f of x is y. So 0 is equal to negative 3 over x minus 1 minus 2. What we said is that we are moving this one to that side. 2 is equal to negative 3 over x minus 1. And make that a 1 and then cross multiply. 2 into x minus 1 should give us a negative 3. Okay, open that up. 2x minus 2 gives us a negative 3, which means 2x, when I move this to that side, it's going to be a plus. A negative 3 plus 2 is going to be negative 1. Then x becomes negative a half. So the graph is cutting the x-axis at negative a half. This origin is here, the O. Now, since they want the values of x for which the graph is above the x-axis, greater or equal to 0. So from this point, okay, so between this point and that point, the graph is going to be above. But remember, the graph cannot touch this one. So I'm going to say negative a half is less or equal to x is less than 1. Okay, it can touch the negative a half, but it cannot touch the positive 1 of the x. Okay, so that is what we had to do with that question. So technically, we had to look for the x-intercept and then give that interval. All right, 5.5 for 2 marks. If f undergoes a transformation to h, where the domain of h is the same as that of f. Okay, so the domain is the same. We're not changing this one. Okay. And then the derivative of h is negative. So when you talk about derivative, we're focusing on the gradient. Must be negative on its domain. Describe the possible transformation that f could have undergone to result in that. So for us to have a scenario like that, where the domain is just the same, unaffected, because if you reflect about the x, okay, the domain is gonna do that. Domain will stay the same, but then the range is going to be affected. And then the gradient of the derivative or the graph is going to change. So the easiest, okay, is just to reflect around this asymptote. Okay, so this must go up and then this must come down, something like that. In that way, we have preserved our domain, and then we've also preserved the range, because they told us the domain and the range will be the same. Reflecting about the x does affect the range, okay? Reflecting about the y will affect the domain. So the easiest way or the quickest answer was just a reflection about the line. Reflection about the line, y is equal to -2. Or reflection about the horizontal asymptote. So that was what was expected with that for question 5. Question number 6, which is a parabola and a straight line. So we've been told that in the diagram below, the graphs f of x, okay, they gave us the equation, and g, which is a straight line, are drawn. C is another point of intersection of f and g. EH is drawn parallel to the y-axis, with E a point on F and H. Perfect, perfect, perfect. 6.1. They want us to get the coordinates of B, which is the turning point. Now, we were given the general format of a parabola. For us to get the turning point, it's your choice now as candidates of grade 12, because you know about calculus. You can use the calculus, or we can just use the grade 11 approach, negative B over 2A. So our B is a 4. So negative with a 4 over 2 times -1, which means that the x value is a 2. They want the coordinates, so which means we need to substitute this 2 into the original equation. So it's going to be -2 squared plus 4 times 2 plus 5. That's 13 minus 4, which is a 9. So which means the coordinates of B are 2 and 9. Beautiful. Then 6.2, can we show that the equation of the line AC is given by 2x plus 2? So we know that the general equation of a straight line is always in the form of mx plus c. So our target is to look for the gradient and then the y-intercept, okay? For us to do that, we need 2 points. We already have point C. We can find point A, okay? Point A is the x-intercept, okay, of both graphs. Let's use the graph of f to find coordinates of A. Okay, so from f of x, I'm going to equate it to 0. So it's going to be -x squared plus 4x plus 5 is equal to 0. Divide through by negative x squared minus 4x minus 5 is 0. Let me factorize this. That is x and x. You can use 5 and 1. This can be negative. This can be positive. So solving this, x is a 5 or x is a -1. So A is on the negative side of the graph, okay? So which means coordinates of A are -1 and 0. Coordinates of C are 3 and 8. So my gradient is going to be change in y minus the change in x, which is going to be 8 minus 0 over 3 minus -1. So 8 divided by 4 gives us a 2. Okay? So if the gradient is a 2, remember we're just proving, so you need to show all the steps. So if the gradient is a 2, we just need to, I can use point A again and say y minus y1 is equal to m into x minus x1. Okay? If I use -1 and 0, that's going to be y minus 0 is equal to 2 into x minus -1. So y is going to be 2x, that's going to be a plus 2. I know it seems like it's a lot, but that was my approach that I thought I could get the answer as fast as I can. Alternatively, because that's going to be something else, I didn't want us to use calculus to find the gradient at this point. It might end up to be something else since this graph is already on the negative side. Same applies to this. So if we get the gradient -2x plus 4, if x is a -1, you see it's going to give us something else. I don't want to go there. So this would be the quickest. Okay, 6.3. 6.3. They're telling us to calculate the maximum height, EH. The keyword here is maximum. Maximum, EH. So since this is the distance between two graphs, we must get the top graph minus the bottom graph. Okay, so that's going to be f of x minus the g of x. So our f was negative x squared plus 4x plus a 5. We're subtracting the g, which is 2x, plus 2. Okay, so this gives us the expression for determining the distance between any points along the two graphs. So this is going to be negative x squared plus 4x plus a 5 minus 2x minus 2. And I simplify this by collecting the like terms. That's going to be 2x plus a 3. But we know that for EH to be maximum, we must find the derivative. Okay. Alternatively, you can use x is equal to negative b over 2a. So that's going to be negative 2 over 2 times negative 1, which means the maximum is happening at x is equal to 1. If I find the derivative, that's going to be negative 2x plus 2 is equal to 0. Move the 2 that side. Divide both sides by negative 2, so which means x is a 1. So now, how many marks is it? Should be 5 marks this question. It's 4 marks, okay. So what we need to do is that the x value is the same at this point or via that line. So I need to get the y value at h, find the y value at e. So if I use my equation here, replace x with a 1, this is going to be 1 and 4. If I use the parabola, replace x with a 1, that's going to give me negative 1 plus 4 plus 5, which gives me 8. So it's 1 and 8. Okay, so we say that coordinates of E is 1 and 8. Coordinates of, is it F or H? It's H. Coordinates of H would be 1 and a 4. Now, since they want us to get the distance EH, just subtract, which is 8 minus 4. The answer must be just 4 units. Okay, this is just one alternative. Whichever alternative you get or you use, you should get more or less the same answers, which is 4 units. Then 6.4, are telling us that if we are given q of x being f of x plus m, so this m represents a transformation or a translation. We are moving the graph, m units, is equal to this whole thing, determine the value of m such that g is a tangent. So one thing we know about any graph and a tangent is that they must meet at one point, okay? So the equation of g is not changing. So what I'm going to do, I'm going to get this whole expression and say k of x must equate it to g of x and use my probability nature of roots. Okay, so it's going to be negative x squared minus 2mx minus m squared plus 4x plus 4m plus 5 must give us 2x plus 2. Let's move everything on the other side. Which side am I moving everything? Let me move everything to that side so that I have just positive x squared. So that's going to be x squared plus 2mx plus m squared minus 4x minus 4m minus 5 plus 2x plus 2. These signs stay the same. It's equal to 0. Doesn't matter where you put the equal sign, okay? Then I have the x squared. Then I'm going to combine the like terms, okay? So this has something with x. I need to simplify this. Then I also need to simplify that. Okay, so it's x squared plus 2mx. Then plus m squared. We say this and this is going to give us a negative 2x minus 4m. This and this will give us a negative 3 is equal to 0. So maintain the x squared, and then I'm going to group this together with this. What is common? The x is common. So I'm going to say x into, I have 2m minus 2. Then this one, this and this should be left on their own. So m squared minus 4m minus 3 is equal to 0. So I kind of have a quadratic, okay, whereby this is going to represent my C, this is going to represent my B, whatever I have there will represent my A. Now, from our nature of roots, we know that roots can be equal if the discriminant b squared minus 4ac is equal to 0. Now, if I try to substitute that, do I have enough space? Okay, let me just punch it here. So it's going to be 2m minus 2 squared minus 4, the a is a 1, okay, and then the c is the whole of this. So m squared minus 4m minus 3 is equal to 0. Let's open up here. We have 4m squared. This is 2 times 2, 4 times 2 again, which is 8m plus 4. We open this, minus 4m squared. This and this is going to give us plus 16m. That and that is plus 12 is equal to 0. Okay, collect the like terms. The 4m's will cancel. Beautiful. Then we just left with this minus 8m plus 16m, which is going to give us a positive 8m. And then 4 plus 12, that's going to give us plus 16 is equal to 0. So 8m must give us negative 16. Divide both sides by 8. So which means m is negative 2. All right. So that's how we get those 5 marks. And that's the end of question number 6. All right. We're flowing. Question number 7. So if there are any errors, guys, any misconceptions, please just bring them up in the comment section. We shall rectify. Remember, I had to rush through this paper fast. Then 7.1, Mary's grandparents deposited 5,000 into a savings account on the day she was born. Mary is lucky, né? The account pays interest at a rate of 6.8% per annum compounded quarterly. Calculate the accumulated amount in this account on this planned kid's birthday. All right, so 16th birthday. All right, so what we're going to do, I'm going to say A is equal to P into 1 plus I to the exponent of n. Okay, let's do the substitution. So we have 5,000, since this is a lump sum, plus, that is 6.8%. I'm dividing it by 4 to the exponent of 16 times 4. Okay, so all I have to do is just punch this into the calculator. So I'm using 16.8%, so I'll use the percentage symbol. Alternatively, you can use the 0.0068 over 4. So 5,001 plus, we have 6.8% over 4. All right, to the exponent of that, I'm getting 147, okay, 06, 14,706.56, around about that value. Okay, so that is 7.1 for 3 marks. No? Then 7.2, we saw this question, I think it was last year, but the other one had value depreciating to 0. This is now depreciating to half. Okay, after 4 years, the value of the printer was half its original value. Determine the rate at which the value of the printer depreciated over this period if the depreciation was straight line. That's the keyword. So let's refresh this page. Just that. Okay, so that we get more space. Okay, so what we're doing, is that we're going to use the straight line depreciation. Okay, so that's going to be A is equal to P into 1 minus IN. Now, we don't know what the book value is, but they told us it's just half. Okay, so if the original value is P, which means this must be a half of P. 1 minus, how many years are we looking at? 4 years. So minus 4i. Divide both sides by P, so a half is equal to 1 minus 4i. Move the one that side, gonna get negative a half is equal to negative 4i. Divide both sides by negative 1, you'll be left with a positive a half. Or why don't we divide both sides by negative 4? So over negative 4 over negative 4, we end up with just 1 over 8 is equal to I. But since we're talking about interest rate, we just have to multiply this thing by 100. So which means our I becomes 12.5%. All right, so that is 7.2 for 2 marks. 7.3, Paul was granted a loan of 100,000 on the 1st of March, 2022 at an interest rate of 13.5% per annum compounded monthly. Paul agreed to repay the loan over 5 years in monthly installments of this much. Okay, starting from the 1st of April, which is the correct orientation of how the loan must be repaid. Calculate the total interest that he will pay over the 5 years. Now, we know that interest is the extra that one must pay, or the extra that must be earned on any investment. So interest can be calculated by getting the final value minus the initial amount that was borrowed or something. So Tsepo is going to pay, let me just say, he's going to pay 2.3,98 multiplied by how many months? 5 years. So that's 5 times 12, which is 60 payments. So times 60, this amount, you subtract your 100,000. The extra is what Tsepo paid. So that's going to be 38,058,80. So that is the extra that Shepo had to pay. So 2.3.98 times 60 minus 100,000. Okay. 7.3. 7 marks. Yo. Tsepo paid 22,300.98. Okay. Which means it was the monthly installment and some additional amount of 20,000 on the 1st of March, 2024 into the loan account. He continues to pay the original monthly installments after how many months earlier will Tsepo repay the loan? Let me try to have something like a timeline here. Okay, so if this is the 1st of March, okay, 1 March, this is 2022. So we have 2024. How many years are those? Around about 2 years, from March up to 1 March 2024. That's like 2 years. And then we have another 3 years up until 2027. 1st March 2027. Okay. So if at this point the guy is paying 22,300.98, it's more like a bonus or an addition. We need to see how many payments did Tsepo make between the 1st of March 2022 and the 1st of March 2024. So since it's 2 years, it's not going to be 24 payments. Remember, he started the payments on the 1st of April. So I'll be looking at 23 payments. Okay. And then from the 60, what's 60 minus 20? 23. That is 7. So we have 37 payments that must be paid after. All right. So what I need to do, or what I'm going to do, my approach would have been getting the outstanding balance as of the 1st of March 2020, before this payment was made. What was the outstanding balance with this period? Then after getting that outstanding balance, I'm going to subtract this deposit, okay? And then from that deposit, I'm going to use it, or the answer that I get, I'll use it as my present value, and then look for the N that will be left for the loan to be completed. And then I'll take it from there. Okay, so what we're saying is that the outstanding balance after 23 payments have been made. So OB is given as x 1 minus 1 plus I to the exponent negative n over I. So if it is 23,98 into 1 minus 1 plus, we said it is 13.5%. What is the compounding? It's monthly, okay? So over 12, the exponent of negative 37, everything is over 13.5% over 12. Okay, so my outstanding at this point is 69,325,998. Okay, I'll make it 26. I round it off. Then I need to go down now and subtract. So the balance will be 69,326, subtract the 22,300,98. And that is done. We shall have 470.25,02. Okay, that is now what is outstanding. Then I need to get the number of months or installments that must be made to clear this balance. So from our present value, we know that x1 minus 1 plus I to the exponent of negative n over I. Okay, I beg to differ with this particular question. So if that is 47025,02 is equal to the 2300,98, 1 minus 1 plus 13.5% over 12, this is negative n. I'm dividing this by 13.5% over 12. Okay, so what I'm going to do, I'm going to multiply both sides by this and then divide, or divide and then multiply. So 47025,02 divided by 2.3,98 multiplied by 13.5% over 12 must give me 1 minus this entire thing. And I simplify that, getting 1,01125 with the exponent of negative n. Simplifying this whole thing is giving me, it's not that. I'm getting an answer because I need to move this one that side, subtract it. It is going to give me negative 0.77008 is equal to negative 1,01125 to the negative n. Divide both sides by negative and then apply the logs. Okay, that will be positive, and then negative n is equal to the log of 1,01125, 0.7708. So negative n is giving me negative 23.35, which means we're gonna have 23.35 payments, which is like 23 full payments, and then there's an extra, which means n is approximately 24 payments. that must be made. Now, if we're looking at the 60 payments minus the 23 payments that were made, okay, and then I subtract also the 24 payments that must be made to clear that. I'm not going to include that other payment of, because this was more like a lump sum, okay, that was made at once. Had it been that it was just the 20,000 extra and so on, then it would have made sense. Okay, so that's gonna be 60 minus 23 minus 24. 60 minus 23 minus 24 is gonna give me 18 months earlier. So the loan is gonna be paid up 13 months before the due date. That's because of that lump sum. All right, question number 8. 8.1, they want us to find d, 3x minus 5x squared dx. So it's just the derivative of that, okay? Regardless of how they tune it and try to confuse people. So using our rules, that's going to give us just 3 minus 2 times 5. That's a 10 with x. That's the answer. And then 8.1.2, we have 2 over x squared. 8.1.2. Okay, we say 2 over x squared minus, we have the cube root of x to the 7. So we need to change this, take it on top, 2x to negative 2 minus cube root is going to be x 7 over 3. Then we start with the derivatives. So g prime of x is going to be negative 4x, subtract 1 is a negative 3. Then that's going to be negative 7 over 3x. When we subtract 1, it's going to give us 4 over 3. 4 over 3. So that is what I'm ending up with, 8.1.2. Then 8.2. 8.2, determine the equation of the tangent at this point. So we have a cubic function. Now they want us to get the equation of the tangent. So one thing we know, or one thing that we need to know is what is the y value at this point 2? So let me start by finding that. What is f of 2? So that's going to be 2 cubed minus 4 into 2 squared plus 2 times 2 plus 3. My humble calculator is giving me negative 1, because that is 8 minus 16, which is going to be negative 8 plus 4, so negative 4 plus 1, no, plus 3, we get a negative 1. So which means we have 2 and negative 1. Okay, that is the first step. Second step is for us to get the gradient. Okay, gradient, we have to find the first derivative. So it's x cubed. Let me jot it aside. Okay, it's x cubed minus x cubed, we're saying minus 4x squared plus 2x plus 3. So f prime of x is going to be 3x squared minus 8x plus 2. Let's substitute the 2 so that we get the exact value of the gradient. So 2 squared minus 8 times 2 plus 2. That is going to be 12 minus 16 plus 2. 14 minus 2, which is negative 2. So we have the gradient of the tangent as negative 2. We have a point which is 2 and negative 1. So let's use that and find the equation of that line. So from y minus y1 is equal to m into x minus x1. So it's going to be y minus minus 1 is equal to negative 2 into x minus 2. Open this up. Y plus 1 is equal to negative 2x. That's going to give us a plus 4. Move the one that side, which means it's negative 2x plus a 3. So that becomes the equation of the tangent. All right, then 8.3. f of x is negative 6x squared. Okay, they want us to find the first derivative from first principles. This is usually the first question of calculus, but people wanted to confuse us. Nevertheless, it's there. Let's kill it. So if f of x is negative x squared, you know that our f of x plus h will be negative 6 into x plus h squared. The formula for the first principles is f of x plus h minus f of x over h as the limit of h tends to 0. We do the substitution, so negative 6 into x plus h squared minus our f of x is a negative, I'll use a bracket there, over h, we keep the limit as h tends to 0. Then we need to just open up that bracket because that is the most important aspect. So negative 6, let me set the limit as h tends to 0. Negative 6 there, I have x squared plus 2xh plus h squared. So negative and negative, that's going to give me plus x squared over h. Then the limit as h tends to 0, I'll open that up, negative 6x squared minus 12xh minus 6h squared plus 6x squared divided by h. So we need to cancel out some common terms. So we know that this cancels that because the signs are different. Then our next step will be to factorize out the h. So h come out, we have negative 12x minus 6h over h. So this h cancels that h. Time for substitution, where h is a 0, which means we're going to end up with a negative 12x. All right. Then 8.3.2, they want us to write down how you will restrict the domain of f such that f negative 1. So this f negative 1 is the inverse, not the derivative. So that is a function. So f is a parabola, and we know that this is a frowning parabola, which will be in that sort of format. If x is 0, y is 0, so like that. So for us to restrict this, either x must be less or equal to 0, so that we have just this negative part, or we can use the x is greater or equal to 0, so that we have this other one for the positive section. All right, then 8.3.3, they're telling us to determine the inverse. Okay, for which the inverse is less or equal to 0, we must write the answer in that format. So we know that initially f of x is negative x squared. So switch them around. So that's going to be x is equal to negative 6y squared. Divide both sides by negative 6. So x over negative 6 is equal to y squared. And then we must find square roots. So y must be x over negative 6 and the square root, or it can be negative x over 6. And then you tell us x must be less or equal to 0. So jot it in this format or just in that format. This is the equation that they wanted. All right, question number 9. This was a weird question. Very weird. Telling us that A is 1 and 9, B is 5 and 1, 5 over 2 and 8 are the turning points, this word, of the graph. C, which is the y-intercept, is there comfortably. They want us to determine the values of x for which f is decreasing. So that can be obtained from the turning points, okay? So before 1, this graph is increasing, okay? That's a plus. Then between A and B, the graph is decreasing. Then after B, the graph is increasing. So since they want the values of x, we're going to say 1 is less x is less 5 over 2. Answered. Then 5.2, write down the x-intercepts of the first derivative. Now, one thing we need to know is that these turning points here, okay, these turning points will become the x-intercepts of our derivative. Remember, this is a cubic, so the first derivative is going to be a parabola. So the turning points will be the x-intercepts. So write down the x-intercepts. So we can say x is 1, and then x is 5/2. Okay, you can also give it in coordinate form where you say 1 and 0, and then 5/2 and 0, since the y is a 0 for the x-intercept. The 9.3, for which values of x will the graph of f be concave upwards? So concavity, when we have the turning points, will be just the midpoint of that, or the midpoint of this x value. So the axis of symmetry of this parabola of the first derivative. So which we can get using the midpoint formula. So 9.3, I'm going to say 1 plus 5/2. Then I'm going to divide this by 2. Okay. So we know that 1 plus 5/2 is going to give us, is it 7/2? 5/2, we get 7/2. Then you divide by 2, you shall get 7/4. So at x is equal to 7/4, that's where the concavity is happening. But since it's concave up, which means x must be greater than 7/4. That is the answer they needed. The 9.4, for determine the values of k, or the value of k, for which y is equal to f of x plus k, will have 3 distinctive positive intercepts. Okay, so what we need to look at is the y values here of the turning points, because these are going to play a bigger role. Okay, so if we move this graph 9 units downwards, because this k is just a shift vertically, up or down. So if you move it 9 units, this point is going to be here. The turning point is just going to be there. And then this one will be slightly below. And then in that case, we shall have 2 points. Okay, so if it is 2 points, remember we want 3 points. If we move it further, we're only going to have 1 point. Okay, but now if our value is between 0 and 9, so this will be slightly above, and then we shall also have that. So it's 1, 2, and 3. So which means our values must be between 0 and 9, okay, for us to get the exact answer that we need. So since this is also 8, it would be more or less the same thing. If we drop it 8 units, okay, if you drop it more than 8 units, just 8 units, just going to be at that point. And then we shall have just more or less like 2 points. You drop it further than that, then we shall create the balance that we need. So in this case, what I'm going to do, I'll use -8 is less k is less, -9 must come first. Okay, so it's -9 less k, then -8. Just like that. K must be between those two values. All right, then question number 10, which is the rates, okay, the application. Telling us a cyclist rode from town P and stopped at town T. The speed in kilometers per hour at which the cyclist rode is represented using this equation. Note that speed is the rate of change of distance with respect to time. Calculate the maximum speed. So remember, this is a quadratic expression. For us to get the maximum, you can use your axis of symmetry, -v/2a. You'll get the value for t, and then we substitute that t into the speed equation and get the maximum speed. Alternatively, we can find the derivative of this. Already it's a derivative, so we have to find another derivative. Okay, so I'll say s double prime is going to be -60 plus 18. And then I have to equate that to 0 because the gradient at the maximum must be 0. So -60 is equal to -18, which means t is a 3, where I'm having my maximum speed. Then I'll get this 3, and then substitute it there so that I get the speed that they want. So S prime of 3 is going to be negative 3 times 3 squared plus 18 times 3. So 18 times 3 is 54 minus 27. I'm getting 27. So my maximum speed is 27 kilometers per hour, per hour, per hour, per hour. All right, then 10.2, they want us to get the distance between P and T. There is a debate of how to get this. But what we can do, let's use the simple formulas of speed is equal to distance over time. Now, since they want the distance, shall get the speed times the time, which is like the average speed. Now, what we can start with is look at the speed initially, okay, at T0. When T0, the V is also 0, or the speed is 0 kilometers per hour. Now we know that at T3, that's when the maximum is attained, which is 27. So now, since it is a parabola in this sort of format, that's T, and probably this is the speed. Now, we know that this maximum here was obtained at a T3, which means we have 3 hours, and then, is it in hours? Yes, and then 3 hours left, using that other half. So I'm going to get my average speed. Okay, average speed will be the speed of the 2, which is going to be like 27 plus 0 divided by 2. That gives me 13,5. So if it is 13,5, this is going to be kilometers per hour. It's just more like for 1/2 of it. Now, if I'm talking about 2 halves, which means I'm going to multiply this by 2, which gives me 27 kilometers per hour, which is more or less like what we got. Then for me to get the distance, it's going to be speed times time. Now the speed is 27, and then the time, remember this is 3, this is 0. So this has to be a 6. So we have 6 hours with which this guy was riding or whatever I was doing. So 27 times 6. Is it going to make sense though? Is it times 3 or times 6? 27 times 6. No, that is going to give me something else, which means I'm doing double counting. Double counting. I've already covered that time. So it's going to be times 3. And 7 times 3, which is going to give me the 81 kilometers. 81 kilometers. All right, so that is that. That is how I would have approached that question. So the distance between the two towns is basically 81 kilometers. The time taken is 6 hours. All right, then question 11. Question 11. Are telling us that a certain number of learners are sitting for exams in maths, tourism, as well as geography. All these learners sit for at least one of the exams. Okay, what this means is that with our Venn diagram, we don't have people that don't sit for anything. Everyone is catered for. So the total number of, let me just draw the Venn diagram as per the question. Okay, so let me call this maths, and then let's call this tourism, and then the mighty geography here. All right, then telling us that maths must be 22, which means this circle must add up to 22, this circle must add up to 16, and then this circle must add up to 18. The total number of learners that are sitting for geography is that, okay, so 5 learners sit for maths and tourism, but not geography. So maths and tourism is 5, so that is where the 5 is. Then 4 learners sit for maths and geography. These are 4 learners. And then 3 learners sit for tourism and geography. That is 3. 6 learners sit for only tourism, which is that. Now they want us to complete this. Now we can use the first set. We need to find what is here, because 6 plus 5 is 11, plus 3, that's 14. What is shorting? It's 2. So which means that is a 2. Then if this is 18, we already have a 9, which means we need a 9 there. Then this is a 9 plus 2, that's 11. We need 11 there. So we're done with that diagram. Then 11.2, calculate the probability that a learner chosen at random will sit for at least 2 in capital letters. So at least 2, it simply means they can be 2 subjects or 3. Minimum is 2. So which means we have this area, we have this area, we have that area, and then even the intersection of the 3. So it's going to be 4 plus 5 plus 3 plus 2. That's 9 plus 5, which is a 14. The total number of learners I have altogether will be that 14 plus 6, which is 20, 20 plus 20, which is 40. So 14 over 20, which is 7 over 20. 14 over 40, 7 over 20. 11.3, determine if the events sitting examinations in maths and sitting examination in tourism are independent. So the rule for this is that maths and tourism should be equivalent probability of maths times the probability of just tourism. Okay, so how many learners are doing maths and tourism? We have the 5 plus the 2, which gives us 7 over 40. Then how many are doing maths altogether? They are 22 over 40. How many are doing tourism? They are 16 over 40. So 7 over 40 is giving me 0.17. And then on my right-hand side, if I simplify this, I'm getting 0.22. So if I'm to look at one number after the comma, remember the question did not do the otherwise to say that we must use one number after the comma. So we're using 2 numbers as per the initial instructions. So these 2 are not the same, okay? For as long as the left is not the same as the right, therefore events are not independent. Events are not independent. Question number 12, finally. A company generates 4 characters. Okay, a company generates 4-character code using 26 letters of the alphabet and then 10 digits from 0 to 9. Determine how many different codes can be formed if the letters and the digits may be repeated. So with this, I have 1, 2, 3, 4. So what I'm looking at is with the letters, we are repeating it. So we have 10 digits to choose from. We said letters. Why am I using numbers or digits? So letters, we have 26 to choose from. Okay, then the digits, we shall have the 10. And then the letter, we shall also have the 26 again. And then we have a 10. So 26 squared times 10 squared. Okay, we're getting 600. All right, so that is the number of codes that we have. Then 12.2, they want us to determine how many different codes can be formed if we have a whole lot of conditions. Ne? Let's see, 1, 2, 3, and 4. These letters may not be used. So it's 1, 2, 3, 4, 5, and 6, which means we have 20 letters to play with. Then the code may not start with a W or a Z. So which means the starting letter will be -2 there, which means we have 18 options to get the starting letter, okay? Then letters or digits, we're not repeating them, okay? So if this is 18, which means 1 digit is gone already, we have 19 options to choose from. That's where we shall get our next letter. Then let's look at the digits. They're telling us that the code ends with odd digit. So odd are basically those numbers of 1, 3, 5, and so on. We have 5 of them out of the 10. So which means we have 5 options to choose from. And then here we shall have 9 options since this one will be taken. So it's going to be 18 times 9 times 19 times 5. That is going to give me, we said 18 times 9 times 19 times 5. So that is 1, 3, It's not 1, 3, it's 1, 5. Okay, so that's 1, 5, 3, 9, 0. That's what we get. Then 12.3, if we modify the conditions and increase the 4 character codes formed in question by allowing these letters to be used. Okay, so which means our letters are back to 26. Calculate the percentage increase. So the letters are back to 26, but then the condition of the digits are not repeating still sticks or stays the same. So out of 26, remember, we're not starting with these two. So which means we have 24 options to start with, okay? And then with the numbers or with the digits, we said it's gonna be a 9. And then out of 26, 1 digit is gone for the first place. We have 25 left. And then we shall have 5 to choose the last digit, since it's also going to be odd. So 24 times 9 times 25 times 5. 24 times 9 times 25 times 5. What are we getting? 27,000. Now, for me to get the percentage increase, it will be now the 27,000 minus the 15,390 over the 15,390 times 100%. Okay, so when I punch that into my calculator, I'll get 75.44%. So this will be the increment that we shall have. So guys, that brings us to the end of this paper. Remember, this is just the proposed memorandum. The actual memorandum is going to come out maybe June next year, okay, to be official. So if there are any issues, please feel free to slot them under the comment section. I feel like this paper was just fair enough. I wish you all the best in your preparation for paper 2. Let's meet then. Bye-bye. So, and welcome to yet another session where we shall be looking at the proposed memorandum of the grade 12 mathematics paper 1 for November 2024. Okay, so the paper was out of 150, 3 hours was the duration of the paper. And then looking at the instructions, this time we have 12 questions. Okay, all questions are compulsory. We have to number questions according to that. Okay, clearly show the calculations, diagrams, and graphs that you have used in determining the answers. So we need to show all our workings. We have the calculator good, and then the rounding off is still 2 decimal places. Diagrams are not accurately drawn, and then we have the information page. All right. So question number 1, as usual, it is the algebra. And 1.1, they want us to solve for x. So what we can do, or what we can see, is that 1.1.1, we have dot product, or we have vectors. So x multiplied by x minus 3 is equal to 0. So in this case, either the x is a 0, or the entire bracket x minus 3 is equal to 0. When we solve this, x must give us a positive 3. So x is a 0, and then x is a positive 3. Those are the two answers for 1.1.1. Then 1.1.2, we say whenever we have correct 2 decimal places, that's going to be the quadratic formula. But before we start with the quadratic formula, we need to create the standard equation where everything needs to be on one side of the equal signs, and then we should be left with a 0 on the other. So that's going to be 2x squared minus 4x plus 1 is equal to 0. Okay, so from that, we can notice that our a is a 2, and then our b is a negative 4, and then our c is a 1. Then all we have to do is substitute into the quadratic formula. Let me just put it aside. So it is 2x squared, okay, minus 4x plus 1. So x is negative b plus minus the square root of b squared minus 4ac over 2a. So that's going to be negative and negative 4 plus minus the square root of negative 4 squared minus 4 times 2 times 1 divided by 2 times 2. All right, so simplifying that, I'll have a positive 4 plus minus the square root. We know that 4 squared gives us 16 minus 4 times 2, that's 8. So 16 minus 8 is going to give us 8 divided by 2 by 2, which is a 4. All right, then when I punch this into the calculator, I'm going to have 4 plus the root of 8, saying 4 plus root of 8 over 4. That gives me 1,71. And then the other value, if I use the minus, I'm going to get 0,29. Okay, so that is what was expected for the formats. Then 1.1.3 is the quadratic inequality. So let's vectorize that. That's going to be x. That's also going to be x. We can have a 3, can have a 1.